All right, this is the Unit 2 test review for the pre-AP test. So again, this whole unit's been about absolute value, so let's make sure we remember that absolute value represents the distance. It's all about the distance. Remember, distance has to be positive between a number and 0 on the number line. Okay, so when we're dealing with the equations, remember we have to isolate everything. So I want to get the bars by themselves. So what I need to first do is I need to subtract 5, and that gives you -2 times the absolute value of 2x minus 6 equals -4. And if I divide by -2, divide by -2, what I end up with now is the absolute value of 2x minus 6 equals 2. Alright, so now I can start breaking it up. So once you're out of the bars, you want to set it equal to a positive, and you want to set it equal to a negative. And then I'm just going to start solving it like a two-step equation. So add 6, you have 2x equals 8, divide by 2, divide by 2, x equals 4. Alright, and then over here, if I start working it out, I'm going to add 6. That gives me 2x equals 4, divide by 2, divide by 2, x equals 2. So those are my two solutions. Okay, on number 2, again, I'm going to isolate. So I'm going to subtract 12, So now I have 3 times the absolute value of x plus 2 equals -7. Divide by 3, divide by 3. Now wait a minute. I'm getting the absolute value, and it's equaling a -7/3. But again, we talked about earlier how absolute value is the distance from 0. So if I take the absolute value of a number, it's all about distance, and distance can't be a negative number. So for this problem, there's no solution. Alright, on the next one, again, I'm isolating the bars. I'm going to subtract 6 from both sides. That gives me the absolute value of 1/2 x minus 4 equals 0. And then I can tell it's only going to be one solution because I can't split up 0 and make it negative or positive. So I'm actually just going to start solving it from here. So 1/2 x minus 4 equals 0. I'm going to add 4. That gives me 1/2 x equals 4 times 2 times 2, and x will equal 8. So that's my one solution. Alright, this one here is already isolated, pretty straightforward. Just going to split it up. So x plus 2 equals 5, x plus 2 equals -5, and then just start solving it. So x equals 3, x equals -7. So those are my two solutions. Alright, on the next one, again, same thing with inequalities. You have to isolate the bars. So for instance, on number 6, it's already isolated. I also notice on number 6 is greater. So remember, if it's greater, my graph is going to look like this. So I'll solve it in 2 steps. This one is less and the graph is going to look like this. So I'm going to solve this as one piece, and this one will be broken up when I solve it into 2 pieces. Okay, so right now I'm just going to start isolating this. So plus 6, that gives me 2 times the absolute value of x minus 1 is less than 10. I'm going to divide by 2, divide by 2. That gives me the absolute value of x minus 1 is less than 5. And then again, you have to have the bad too, the negative also. Alright, so now what I have is, I actually probably should drop the bars here, so I'm going to get rid of these bars. And then I'm just going to start solving it. So I'm going to add 1. So what I end up with is -4 is less than x, which is less than 6. Now those are open circles, so I'm going to do an open circle on -4. I am going to do an open circle on 6, and then connect them. That's not a very good job. Let's just pretend like that looks all nice. Okay, so now over here I'm going to do greater. It's already isolated, so I'm going to split it up. So I have 2x minus 3 is greater than or equal to 1. I also have 2x minus 3 is less than or equal to negative 1. So again, because I have that negative number, I have to flip the sign. So I'm just going to keep solving it. So plus 3 plus 3. So 2x is greater than or equal to 4. I'm going to divide by 2, divide by 2. So for this solution, I'm going to have x is greater than or equal to 2. Or, let's see what else I have. So I'm going to add 3. So 2x is less than or equal to 2. Divide by 2, divide by 2. X is less than or equal to 1. So those are my two solutions. So here, of course it's counting by 2's. So this will be a closed dot on 2, going that way. And this will be a closed dot on 1, going that way. Alright, on this one here, we're graphing the equation. So the first thing you have to do is you have to know where the vertex is. So this is the information I need for the vertex. So my vertex is going to be 1, 3. Alright, and then this kind of represents how I move to find the other parts of my graph. So first of all, I know it's going to be opening down because of that negative right there. So I'm going to go down 2 over 1, down 2 over 1. I can kind of keep doing that just so I can draw it a little bit better. So there it is. Alright, on this one here, I'm finding the solutions of the equation. So again, I got to isolate the bars. So let me add 2 to both sides. So now I have x minus 1 equals 4. And then I'm just going to start solving it. So x minus 1 equals 4. X minus 1 equals negative 4. So I'm going to add 1 to both sides. So here I'm going to have x equals 5. And then I'll have another solution where x equals negative 3. Okay, on the next question here, I'm writing an absolute value equation. So I got to make sure I have an equal sign. So remember, the format is x minus the target equals a number. So here is your target, and then this is your give or take. So it says the water temperature in a certain production process should be 112. So that's going to be my target. If the actual temperature differs by 13 degrees, remember we called that our give or take, from the ideal temperature, then what are the maximum and minimum temperatures? Write the absolute value equation that you use to find the actual temperatures. So the target always goes on the inside, and then the give or take goes on the outside. So again, another way to think of it is biggie, small, biggie, small. Alright, so now I'm going to actually start solving it. So remember, when I solve this, I make one of them positive, and I make one of them negative. So if I add 112 here, and I add 112 over here, I'm going to have x equals 125. This will be my maximum. I'm also going to have x equals 99, and that is my minimum. And again, that is my equation. Now remember, if it's an equation, it has to have an equal sign. Equal sign. Alright, on the back. Alright, this one here, they want you to do an inequality. So remember, it's the exact same idea. X minus a number. This time, though, you got to use less than or equal to a number. So it's the same thing with the target, the give or take, all the same thing. The temperature of a kiln should be 143 degrees. So again, that is your target. The product is defective if the actual temperature is more than 7 degrees. So that's my give or take. Away from what it should be. Write an inequality to represent the temperatures where the product would be defective and find the range of the temperatures. So again, biggie small, where the target goes on the inside, 143, and then the 7 here. Alright, so I'm going to start solving it. So I'm going to have x minus 143 is less than or equal to 7. Now that's my positive, but remember, you also have to have the negative. So I'm going to add 143 to both sides. Okay, so for this one, it can be 136 degrees, less than or equal to x, which is less than or equal to 150. So somewhere around there. Alright, on the next one, it says, use the graph below to describe the transformation of vertex. So here they want me to describe the transformations. So what I notice is that it's reflected across the x-axis. Okay, because again, remember your parent function is right here. That's your parent function. I also noticed that it was moved, it went left 2. And I also know it went down 3. Alright, so if I were to write the equation, the way that we did it in class is we did blanks. So because it was a reflection, I know it's a negative. Now I'm actually going to check the slope right now. So if I come down here, I go down 1 over 1, so it's just 1. I also know it went left 2, so left 2, and it went down 3. So again, that's my template. So if I were to clean this up, I would write y equals negative, and then x plus 2 minus 3. Alright, my vertex here is negative 2, negative 3, and it's going to be a maximum. Alright, on number 12, I'm just filling in the table. So on this one, I have negative 5. So the absolute value of negative 5 is 5, plus 2 is 7. The absolute value of negative 2 is 2, plus 2 is 4. The absolute value of 0 plus 2 is 2. The absolute value of 1 plus 2 is 3. And the absolute value of 2 is 2, plus the 2 is 4. Alright, on the next one, it says the table of values can be modeled by which equation? So these are your 4, so it's a multiple choice. And basically, I wanted to just start looking at each one. So I'm actually going to start with the positive numbers. So I'm going to start with the 6 here. So if I put in the 6 here, 6 plus 5 is 11, and the absolute value of 11 is 11. Well, they're telling me I should get a 1, so that won't work. Here again, I'm going to put in the 6. 6 minus 5 is 1. The absolute value of 1 is 1. That works. Okay, let me try this one. If I put in a 1 here, 1 minus 5 is negative 4. The absolute value of negative 4 is 4. But no, that won't work. That's a negative. I'm going to get rid of that one too. Okay, same thing here. I'm going to put in a 6. The absolute value of 6 is 6, plus 5 is 11. Again, you should get a 1. That's not right. Okay, let me just double check this one. So here, the absolute value of 6 is 6, minus 5 is 1. Okay, that works. Now I'm going to put in a 1. The absolute value of 1 is 1, minus 5 is negative 4. That's looking pretty darn good. Again, I'm going to put the 2. The absolute value of 2 is 2, minus 5 is negative 3. So there it is. The answer is D. Alright, on number 14, right below it, it says, if the absolute value of x minus 3 plus 1 is greater than 4, which of the following could be a value of negative 1? Alright, so on this one here, I'm looking for the greater. So if I start with 3, 3 minus 3 is 0, so the absolute value would be 0, plus 1 is 1. Well, is 1 greater than 4? No, it's not. Okay, if I put in a 1 right here, 1 minus 3 is negative 2. The absolute value of negative 2 is 2, plus 1 is 3 greater than 4? No. Okay, again, I'm going to put in 0. 0 minus 3 is 3, or is negative 3. The absolute value of negative 3 is 3, plus 1 is 4. Well, is 4 greater than 4? No, they're equal to it, so that won't work either. So this must be the answer. Just double check. Negative 1 minus 3 is negative 4. The absolute value is 4, plus 1 is 5, and 5 is greater than 4. Alright, on number 15, it says use the graph below to fill in the parts of A through G. So the first thing they want us to do is find the vertex. Let's find the vertex. So that's going to be at 3, negative 2. Now, I'm going to actually skip down to the axis of symmetry. So remember, your axis of symmetry is that 3, so x equals, you got to write it as an equation, x equals, and again, that just cuts it in half. Alright, your x-intercepts are located at 2, 0, and 4, 0, so there and there. The domain as an inequality, again, the domain is always negative infinity to infinity. If I write it as an inequality, that's what it looks like. Alright, your range is low to high. This is the lowest that it goes at negative 2. So I have negative 2 all the way to infinity. And then they want me to describe the transformations. So the first one I noticed is it went right 2. I also noticed that it went, I lie, it went right 3. Right 3. It also went down 2. And then now I'm going to check the stretch and compression. So it went up 2 over 1, so 2. That makes it a stretch by a factor of 2. Now if I write my equation, I'm going to have y equals, I know it was a stretch, so 2. It went right 3, so x minus 3, remember it looks like the opposite on the inside, and then down 2, minus 2. Okay, on the last one here, this is actually going to be the parent function. So your equation is just y equals the absolute value of x. And again, when I'm talking about all these transformations, it's because I'm talking about it starting from here. I'm having it start from that parent function, and then I'm seeing how it moved. Okay, so the vertex here would just be 0, 0. Your axis symmetry is just where it gets cut in half, so that's x equals 0. Your x-intercept is 0, 0. Again, your domain is going to be always negative infinity to infinity. I cannot stress that enough. It's going to go forever left and right. All right, your range, low to high. The lowest it goes is 0, and the highest it goes is infinity. The graph is symmetric with respect to which axis? So if I were to fold this, I would fold it along the y-axis, and that is what would make it symmetric. Okay, I hope that helped you out. If you need any help, make sure you talk to your teacher. If I made any mistakes on here, please just kind of let me know. And that's about it. Good luck.